Welcome to Point Slope Form by Alan Staub. Here are some notes for you to take. First, we have the actual point slope form, y minus y1 equals m, the slope, times x minus x1, where x1 and y1 stand for the actual x and y coordinates of the point you're given. Because this is point slope form, we're given a point and we're given the slope. Feel free to press pause so that you can copy these notes with the example. Now let's go ahead and work this problem with the example. This is my point slope form. All I have to do is plug in the appropriate numbers. So y stays a variable, minus y1, the y coordinate of my point, equals m, my slope, times x, still a variable, minus x1, my x coordinate. Now my goal is going to be not to leave it in point slope form, but to write it in slope intercept form, y equals mx plus b. So I'm just going to simplify this equation and solve for y to put it in slope intercept form. Watch. I now have my equation in slope intercept form, and I am done. Let's look at another example. I'm just going to plug this information into the point slope form template. So y, still a variable, minus my y coordinate equals the slope times x minus my x coordinate. Now I will simplify and solve to put it in y equals mx plus b form. Let's see, a negative times a negative is a positive, and to do 3/5 times 20, I simply divide 20 by 5, that's 4, times 3 is 12. Now all I have to do is continue solving for y. I now have my equation in slope intercept form, which was my. Turns out there's actually an easier way, at least I feel like it's easier. Since my goal is to write it in slope intercept form, I'm simply going to use that as the template. Well, I already know my slope, and I don't know all the x and y's, but I do know at least one x and one y coordinate. So if it has to work for all of the points on the line, the equation, then this equation has to work for this point as well, because this point is on the line. So it has to work for this x and y coordinate. So I'm going to go ahead and use those to help me figure out the one unknown, and that's my y-intercept. So watch. Y, which is the -3, equals slope times x, which is 6, plus b, my y-intercept, which I don't know. Simplify and solve. So now I know that my y-intercept is 27. I already know that my slope is -5. So writing the equation is very easy now. Y equals -5x plus 27. Lovely. Let's try this quick, easy method with another one. I know I want it to be y equals mx plus b, so I'm going to plug in my x and y from the one point I know and my slope. So the y coordinate equals the slope times the x coordinate plus my unknown y-intercept. So I'm going to simplify. I know that a negative times a negative is a positive, so 5, 6 times 12. 12 divided by 6 is 2, times 5 is 10. This is a positive 10 plus b. Subtract 10 from both sides, we will get that b equals -14. So now, I know my slope is -5, 6. I know my y-intercept. Writing the equation now is easy squeezy lemon peasy. Done. So here are some notes on the quick, easy method. If you want to press pause and take these notes, do that now. If not, we're going to move ahead. Okay, this problem looks different. All the other problems, I told you the slope and a point, hence point-slope form. Here I'm just telling you 2 points. I wonder what we can do here. I bet you've already figured out. Just figure out the slope of the line that contains those 2 points, and then use one of those points. So slope, rise over run. Up top, subtract the y's. On the bottom of the run, subtract the x's. This is equal to 4 over 3, so my slope is 4/3. Now I'll simply use 4/3 as my slope and pick either one of the points. There you go, I'll use this one. And then you do the exact same thing that we've been doing. Either method, either one of the 3 methods that I showed you. Now I will mention that if you have 2 points to choose from, look for the easiest one. For example, for these two, I would almost definitely choose the 2 4/8. If one of the points looks like this, I would definitely choose that point. Think about where 0, 9 is on the coordinate plane. It's probably right here. It's on the y-axis, so actually 9 is your y-intercept, staring you in the face saying, pick me, pick me, pick me. You don't have to figure out the y-intercept. Whoop, there it is. So let's do one full example. I have to figure out my slopes. I'm going to do up top, subtract the y-coordinates. On bottom, subtract the x-coordinates. I believe this is 14 divided by 2, also known as 7, which is going to be my slope. Okay, I like this point, so I'm going to use this. I'll do this by the quick and easy method. Y equals m times x plus b. So now I'm ready to write my equation. Y equals mx plus b. So we can just write minus 46. All right, now for the last 2 problems, these are kind of special. Okay, so the same adheres for when we did just regular slope-intercept form. Okay, this one is so easy. Y equals m times x plus b. Very simply, b equals 4. So it's y equals 0x plus 4, or more simply, y equals 4. We probably could have gotten this just directly because we know that if the slope is 0, it must be a horizontal line. And so if you think about where negative 7, 4 is, right around here, horizontal line, well, what's true about all the points in this line? What's true about all the points in that line is that y equals 4. That's what this says. Well, for this one, let's do it just this way. We know that an undefined line is a vertical line. Therefore, for 5, negative 8, the vertical line, what do all these points have in common? That the x-coordinate is 5. So we can simply skip right to the equation. X equals 5, and we are done. Well, that's all we have for you today. This is Point Slope Form by Alan Staub.